Today, we're going to pull back the curtain on the clothes you wear every single day. And we're going to reveal this hidden battle of science, precision, and just immense force that decides whether a piece of fabric is totally flawless or a complete failure. You know that feeling, right? You buy a brand new shirt, you get it home, and then you spot it, a tiny, super frustrating flaw. Maybe it's a little snag or a weird streak in the color that just seems off. So, where do these things even come from? Well, the answer is buried in the very creation of the material itself. To really get where those flaws come from, we have to start at the beginning, with the fundamental magic of how fabric is even made. It all kicks off with a process that's, believe it or not, both ancient and incredibly sophisticated. At its heart, weaving sounds almost ridiculously simple. You're just taking two sets of threads and lacing them together, over and under to create a stable, flexible sheet. But as you're about to see, that simplicity hides a whole world of complexity. So those two sets of yarns, they have names. First up, you've got the warp yarns. Think of these as the absolute backbone of the fabric. They run the entire length of the roll and they are held under some serious tension. Then you have the weft yarns, sometimes called the filling, which are woven across the width, back and forth, filling in that structure. Okay, so how do you get that weft yarn through a bunch of warp threads that are strung super tight? You create a temporary, triangular opening by lifting some threads up and leaving others down. Now this little opening, it's called the shed, and this is the single most important moment in weaving. It is literally the space where fabric is born. And this all happens in this rapid-fire, five-step mechanical dance. Shedding creates the opening. The filling gets inserted. The bead-up motion pushes that new weft yarn tightly into place. And finally, let off and take up move the whole system forward, feeding in new warp yarn and rolling up the finished fabric. This cycle, it repeats hundreds of times a minute. It's crazy. But for that dance to be perfect, one invisible force has to be controlled with absolute unwavering precision. And this is our story's unseen villain, yarn tension. Now, that might sound kind of obvious, but this quote from a key research paper in the field really puts it plainly. Getting the tension right isn't just a detail, it's a critical factor. Pretty much everything hinges on it. The best way to picture this is to think of a harp. Every single warp thread, and there can be thousands of them, is like a string that needs to be tuned to the perfect pitch. If it's too loose, the music is just sloppy. If it's too tight, the string snaps. Fabric is exactly the same. And this is not guesswork. This is a science of incredible precision. Researchers have actually quantified it. For a standard cotton plain weave, the warp yarns have to be held at a tension between 38 and 39 centinewtons. That's a tiny, tiny unit of force, but it has to be exact. So that leads us to the big question, right? The one at the heart of all of this. What are the consequences when this finely tuned system goes haywire? Because here's the thing, a small imbalance in tension doesn't just create one little problem. Now, it unleashes a whole cascade of defects that can absolutely ruin an entire roll of fabric. This is what that failure actually looks like. Weft bars, those thick horizontal lines you sometimes see. Streaks, broken threads that just leave a gap. Raised threads, called floats, that are just asking to be snagged. All of these are the physical result of bad tension during weaving. But here's where it gets even more interesting. The damage isn't just mechanical or structural. Tension actually affects the fabric at a chemical level, specifically in how it absorbs dye. And this table from the research just nails the point. Check it out. Fabric woven at the correct tension, it passes inspection with a dye uptake value of 12.01. But when the tension is too low, that dye uptake drops significantly and the fabric gets rejected. The yarn is literally less absorbent. So what does that look like in the real world? It translates to a defect called shade variation. It's the reason why one part of your shirt might look slightly off color, or why you see these faint, streaky lines. It's a direct result of tension problems during weaving that you can only see after the dyeing is done. So you see, it's a super delicate balance. It's a real Goldilocks situation. Too much tension can literally break the yarns and deform the whole fabric. But too little tension, that's just as bad. It leads to a loose, uneven structure and that poor dye absorption we were just talking about. Okay, so with all these things that can go wrong, you might be wondering, how does any perfect fabric ever make it to the store? Well, that's where the guardians of quality come in, and they use some really systematic processes to protect that perfection. The key weapon in their arsenal is a standard called AQL, which stands for Acceptable Quality Limit. It's basically a statistical method that lets an inspector assess a huge batch, like thousands of meters of fabric, by just carefully examining a small sample, and then making a pass or fail call based on that. Now, let's be real. AQL isn't about finding zero defects. In mass production, that's pretty much impossible. It's about managing them. The system classifies flaws as minor, major, or critical. And while a few minor flaws might be okay, critical flaws, like holes or big stains, that's an automatic rejection, no questions asked. The whole process is really methodical. When they find a defect, it gets documented with photos. It's graded for how severe it is using a point system. Then, a decision is made. Do we accept it with a discount or reject it completely? And here's the most important part. The team works with the factory to find and fix the root cause, so it doesn't happen again. And all of this brings us to our final and maybe most crucial point: understanding the true cost of actually getting this right. You see, being proactive about quality isn't just another cost, it's a huge investment. Catching a tension problem early saves a ton of money, it prevents massive production delays, and at the end of the day, it protects the most valuable thing a brand has: its reputation with customers like you and me. So, the next time you pick up a piece of clothing, just take a second to appreciate the invisible battle of forces that was won to create it. And it kind of leaves us with one last question to think about. In a world of fast fashion and mass production, what are we really asking for when we demand perfection? And what is its true cost? Thanks for watching.